Graphing using amplitude. So we know what a basic graph, y equals sine of x, looks like. This is our basic y equals sine of x. Now we can change this by changing something called the amplitude, and that changes the height of my graph, the very maximum points and the very minimum points. And I can do that by multiplying by a constant. The amplitude is just the absolute value of that constant in front of my trigonometric function, sine or cosine. So if we take a look at this, we have y equals sine of x, and we choose some values for x, figure out what sine of x is equal, which is how we plotted this graph. So at x equals 0, I just drew a unit circle over here that I could just use as a reference. So at 0 radians right here, my sine value is 0. I haven't moved up at all, so that equals 0. If I look at a new function with amplitude changing, my amplitude's 2 here, I have 2 times the sine of x. So I take the sine of x, which is just 0, and I multiply it by 2. And again, I get 0. So these two graphs share 1 point. And then if I take a look over here at pi over 2, at pi over 2, I'm up here, and my sine value is 1. And so sine of x is 1, and I plotted that right here. If I multiply it by 2, I look at y equals 2 sine of x, I just get a 2 out. And so I can plot that point up here at 2. At pi 0, sine of x is equal to 0. I'm back over here. My height is 0. So I have that on my blue graph, but it's also on my red graph, my y equals 2 times sine of x. And so it shares a point right here. At 3 pi over 2, I notice my sine function is going to be negative 1. So sine of 3 pi over 2 is going to just give me a negative 1. Multiply by 2 and my y equals 2 sine of x, and I have a negative 2. At 2 pi, I'm back at 0 on both of those graphs. So this amplitude, we can see it visually in the graph. It's going up to 2 instead of 1 there, but it is going back down through that 0, that same 0, and over here to negative 2, and then, oops, and then back up. And then continuing down here to negative 2. And then back up. So it just changes the height. That 2 expands my maximum value from 1 to 2, and my minimum value from negative 1 to negative 2. And I would just say the amplitude of this y equals 2 times sine of x is 2. So let's take a look at what happens with cosine. So here I've changed it just a little bit to get you familiar with some of the notation used. I have f of theta, which is like our y coordinate, is equal to 1/3 times the cosine of theta. Now that theta acts just like the variable x did in the last one. So this axis, instead of the x-axis, I just labeled it the theta axis. And this is f of theta. Okay, so let's take a look at what happens with this function. Again, I choose some very basic values. And you could choose values in between there as well and get the cosine and 1/3 times the cosine of theta. So if I choose 0 here for cosine, I have my unit circle over here. At 0, my width right here is going to be 1. So cosine of 0 is 1. And then here, cosine of 0, which is 1, times 1/3, which is just a third. And then pi over 2, I can look at that as well. At pi over 2, I'm up here. My x value is 0. So cosine of pi over 2 is just 0. And then if I multiply it by 1/3, I also get 0. Pi, I get negative 1. I'm right over here. My x value is negative 1. And then multiply by 1/3, I have negative 1/3. So 1/3 cosine theta right there is just negative 1/3 because cosine theta is equal to negative 1. 0 at 3 pi over 2, and then multiply it by 1/3, and I get 0. And 2 pi, I'm back up here at 1, and if I multiply that by 1/3, I just get a 1/3. So the amplitude for this graph, my cosine graph, is 1/3. And I can go ahead and just connect the dots. And notice what's happening to my graph. It shares this 0 point. Ooh, that's not very curvy. There we go. That's better. And then back down, and then up to 0. So notice my height changed. So instead of my maximum value being 1, my maximum value here is 1/3. My minimum value is negative 1/3. And then I still go through those same 0 points because I'm just multiplying by that. Now let's take a look at what happens when you have a negative value in front of your sine or cosine. So looking at y equals negative 1/2 sine of x. Well, the amplitude here is the absolute value of whatever that a value is. So the absolute value of 1/2 is just 1/2. So amplitude's always positive when we talk about it, but it is going to change this graph. So we're taking a look at the graph y equals sine x, and then y equals negative 1/2 sine x. So again, I choose my very basic values, thinking about the unit circle. If x is equal to 0, sine of 0 is 0. If we multiply that by a negative 1/2, that's also 0. Pi over 2 is 1, multiplied by a negative 1/2, and I have negative 1/2. So here I have a positive value, but here I have a negative value. Pi equals 0, I also have a 0, so it's going through these same points. But notice when I have a positive value for sine of x, I'm going to get a negative value for negative 1/2 sine of x. So here I have a negative value of 1 at x is equal to 3 pi over 2, and then that's going to multiply by another negative to give me a positive value. So when I have a negative value for sine of x, I'm going to have a positive value for negative 1/2 sine x. Zeros stay the same. So let's take a look at what happens to this graph. Now, not only are we decreasing the distance, so starting from 1 to 1 here, decreasing it from 1/2 to negative 1/2, we're also changing the positives to the negatives. So anytime we do that, we're changing the positives to the negatives and the negatives to the positives. So it's flipping over the axis. If it was once negative, it's now positive in my negative 1/2 sine of x. And then graphing, oops, here and back down. So when I'm multiplying by that negative, my y values are going to change sign.